Hello and welcome to this series of videos from Math Review. I'm Matthew Woods, Assistant Director of the Academic Support Center here at the College of St. Rose. And before we begin with Lesson 1 here, let me give you a little bit of a background of where all this came from. Last year, I took it upon myself to kind of create an offshoot sort of online review course for our math placement exam. And came up with a few topics to do videos of and came up with assignments and everything, but it never really went beyond just that. So over the course of the year I kind of sat and stewed about it and thought what's the best way I could use all this stuff, because I spent a long time on it, and finally we came to just making these video workshop type things. So that's where these all came from. And the purpose of these videos is not just for math placement review, even though everything says math placement review on it. These videos are also to help you with individual math courses. So if you're having a course where you're having trouble with factoring, let's say, you could pull up the video and pull up the practice sheets from that and still be able to utilize it. So that's where all this is coming from. Now, my goal with these is to make them not much more than about 10 minutes per. So, and some of them might be a lot shorter than that. I'm going to go kind of general topic, like the topic for this one is rules on the behavior of numbers, and go kind of like subtopics in each. So this one I think is going to have 3 videos. And as you can see from the worksheet, right here. So every group of videos is going to have one of these worksheets. This will tell you the series of videos that the worksheet goes with. This will tell you the practice, the topics that we're going to cover, and then we'll just have the practice problems below. Alright, with all that out of the way, we're going to get started with the behavior of numbers. And we're going to start actually doing the classification of numbers. Now, as you can see, I'm working mostly with just one of our document cameras here at the College of St. Rose, recording on Camtasia using Podium View, so that's why things look kind of low-tech. So, there are an infinite number of numbers in our world. And every step of the way we're going to be working with different types of numbers. So we have to know what numbers we're working with and why. So we're going to start off with just classification. So we have all numbers. By the way, ignore this little thing up in the corner up here. That's just Podium View's icon. All numbers can be broken down into one of 2 basic categories, either real or imaginary. Imaginary numbers are the square roots of negative numbers. It's like the square root of -1, which we call I. And we'll be dealing with those in a much later video. Real numbers are basically everything else. So again, that means that there's a lot there. So even that we can break down a little bit. We're going to break this down into 2 other subcategories. Irrational and rational. Irrational numbers are non-repeating and non-terminating. That means there's just no pattern in the decimal, and the decimal values just keep going on forever and ever. The most popular example for an irrational number, of course, is pi. And other irrational numbers are just square roots of things that aren't perfect squares, so like 2, 3, 5, so on and so forth. Rational numbers can be expressed as a fraction. For instance, 0.5 I can write as 1/2. 0.333, and that line on the top means it goes on forever like that, I can write as 1/3. 0.562 I can write as 562 over 1,000. And even with whole numbers, I could write 2 as 2 over 1, 4 over 2, so on and so forth. So, I'll get the mouse out of the way. So that's a rational number. Rational numbers have a few subgroups. First one that we're going to be talking about, and this is one of the most commonly used one in math, let's slide this up a bit, are integers. Integers are the positive and negative whole numbers. So -1, 1, -2, 2, so on and so forth. Those are all examples of integers. And that's something important to remember as we keep going. What I'm giving you here are examples, not definitions. This is the definition. This is a definition. These are examples. Integers we can break down into what's just called the whole numbers, which is 0 to infinity. That little sideways 8 is an infinity symbol. Whole numbers include 0. And we're going to break that down even more into natural numbers. And natural numbers are 1 to infinity. So that means 0 is the only difference between whole number and natural numbers. Easy way to remember, at least to me, was always to have in nature, if there's 0 of something, it doesn't exist anymore. For instance, if you were to say there are 0 pink elephants in nature, well, then we don't care much about pink elephants, so it's not a natural occurrence anymore. Alright, so like I said, I wanted to keep this first one kind of quick and easy, so this is our first video. There'll be a couple more for the first section, so thank you, and I'll see you later.